Hello and thank you for subscribing to InfoWars Tech. Today we are continuing our series on IoT and IIoT systems, and we are exploring Node-RED. As we know, Node-RED is a programming tool for wiring together hardware devices, APIs, and online services in new and interesting ways. It provides a browser-based editor that makes it easy to wire together flows using the wide range of nodes in the palette that can be deployed to its runtime in a single click. So here I am on the Node-RED website, and just showing you, how to browse through and look at the different options that are available. So this is the fourth or fifth tutorial in the series. So I would definitely put the links to my previous tutorials. Be sure to visit them to understand how we can install Node-RED and create some basic flows using the core nodes. And today we are going to look at the Node-RED function. The function node allows JavaScript code to be run against messages that are passed through it. So this is a very powerful core node that allows us to manipulate data in multiple ways. You can do data transformation, data aggregation, and anything that you can create using that function code. It will apply on the message that passes through. The message itself is passed in as an object called message, msg. By convention, it will have a msg.payload property containing the body of the message. So let's get started. I have my environment all set up and ready to go. So we'll be working today in Flow 4. And you can see I have a few examples all set up. So let's go with the first example, which is counting the number of characters in an input. So let's go here and let me type in, let me select string just to make sure string is selected, and let's type in something called InfoWars. Okay, let's save that. And here in the function we will be counting the number of characters. So let me just bring up that piece of code and put it here. So it is, so basically what we're doing is we are creating a variable new msg. You can give it any name, and that equals to payload that we talked about, that's coming inside the message, and then we're saying message.payload and .length. So we're using the property length to determine the total number of characters, and then we're returning that newly created variable which is being assigned this value. So let's save this as well. Okay, now you can see we these are successful, so no errors. Otherwise that's shown by a small triangle. And let me hook it up here to this debug node. Now everything looks good. Let's clear this up and deploy. So that was successful. Now let's try that out. So if I inject that node, so it tells me that it's 15 characters. We can get a little more detail by changing this to complete message object, and we can actually see the pass message as well. So let's redeploy that, and when we inject, you can see that the payload is 15, and you're getting a little more detail. But for our purposes, just keeping it on the message should be good enough. So let's save that. Okay, so that was a very simple function to count the number of characters in a incoming message. So all we did was assign a new variable and give it the value of this .length, and then we're returning that in the function. So that's a very simple example. Let's look at something a little more complicated. So we have, and just to give you a quick OV to see if you can just change the input. So let's say if I add a little more text here, so hello Infoverse and hello world, and when we save that and we redeploy, and when we inject that, so that's 31. So that's indicating, as you saw, we increased the number of the string size has increased, and correspondingly the number of characters has also increased. Okay, let's look at another example where we are inputting a value, a certain value, and we are able to transform that data. So let's go here, let's select a value. Okay, let's say let's represent this as 4,000. Let's say this is somebody's salary, and here we are going to be calculating the tax on this salary of, let's say, 20%. So let me just bring that quickly and show you the code. So, and I'll explain that each line how that works. So if I place it here, so what we're doing is we're saying there's a variable called salary. It is getting the msg.payload.data1, and I'll explain why I added data1 here. Variable tax rate equals to 0.2 or corresponding to 20%. These two lines indicate that anything after this is treated as a comment, so it's not part of the flow. And then another variable called new value, and this is calculated by salary multiplied by the tax rate, and then we need to assign that value back. So message.payload gets the new value, and then we return that as part of the function. So let's save that and let's redeploy. So before we do that, we need to remove this and connect it to this one so that we can get the output here. So this looks good. Let's redeploy and let's run that. So 4,000, the tax rate 20% is 800, which is correct. Let's take another example. Let's make that, let's say 3,200, and let's redeploy. And you can see at this time it gave the right number. Again, it's 20%. I just wanted to show you in the inject node, what I'm doing is I'm saying message.payload.data1, and this adding this property helps me to identify this data later on, as we'll see in the next example. So that was just calculating a basic like a tax rate or something similar. Let's look at something a little more complicated, where we are taking two inputs and we are calculating, or let's say two readings coming from two sensors, and we are required to take the average of those readings. So let me add another here, and here you'll see why I'm using that property. So data 2 to be able to identify that. Let's give this, let's say getting 10 in sensor 1 and 20 in sensor 2. Let's save that. In the function, just going to show you the code. Let's take this out. Okay, so very similar, identifying or creating a new variable sensor 1 that gets the message.payload.data1. So you know that's it's, remember we have two sensors, so sensor 1 is getting data 1, sensor 2 is getting data 2. That's how we set up the inject node. And then we have the average, which is equal to sensor 1 plus sensor 2 divided by 2, the average of two readings. And then the second last line, the message.payload, we assign it the value of average that we get here, and then we return that value as as part of the function. So let's save that. Let's clear this and redeploy. Okay, so we are entering 10 and 20, so expected average should be 15. So 10 and 20 coming in. Let's run that, and it does not look to be right. So let's see what could be the error. Let's go through that again. So sensor 1 getting msg.payload.data1, sensor 2 is getting msg.payload.data2, and then we are combining sensor 1 plus sensor 2, and it's divided by 2. Okay, so this part looks okay. Let's see what the issue is. Let's look here. So what are we inputting? We are inputting, did you see that error? So that's we're inputting 20 as a string, and that is causing that issue. So let's change that both to numbers as it should be. Let's save that. Let's redeploy, and now when we run that, we should get 15. Great. So let me put another number just to change. So maybe the readings changed. I went to 25 and 25, and let's redeploy, and we should get 25. So that's working fine. Okay, good. Let's look at something a little different. So let's try to simulate something that happens in or a real use case where readings are coming in intervals of 5 or 10 seconds. So let's modify that in the inject node to set it up that way. To be able to simulate that, let's change this to an expression, and let me just create these random numbers just to do that kind of a simulation. And over here, let's create it with just making this up. Okay, and what we want to do is inject them let's say every 10 seconds. Right, so the use case we are simulating is that we have two sensors, they're sending readings, and the readings are coming in every 10 seconds. So let's save that. So let's redeploy and just clean this up so we get a clear reading. So let's run that now. Okay, so every 10 seconds, two readings come in from sensor 1 and sensor 2. They get an average reading taken, and then that's displayed. So depending on the numbers, because we're generating random numbers, and this will continue every 10 seconds, you will be getting different values each time. So this is a good way to simulate how if you're doing like a POC for somebody in the IoT and IoT industry. This is a very simple example of simulating how as readings are coming in, we can transform that data and show you the results. This result can be populated into a CSV or an Excel file, and then it really becomes very useful data for the customer. Okay, so let's stop that, and let's do a final example. So let me just stop these here, and let's go to the next example. So in this example, we'll be doing a temperature conversion from Fahrenheit to Celsius, and then Celsius to Fahrenheit. So let's look at that example. So let me call this Fahrenheit to Celsius, and let's say the it's coming in as, let's say, 40 degrees Fahrenheit. Let's save that. Let's connect this guy here. So we're looking at example 4 now. So that's Fahrenheit to Celsius. We need a function that is able to convert that. So let's see the function that I have. It's gonna copy it here. Okay, let's try and explain that. So we have a variable. We are defining a variable called Fahrenheit, and it takes the value that's coming in via msg.payload. Then we define a variable called Celsius, and that's equal to Fahrenheit minus 32 bracket close multiplied by 5/9, and that gives us a corresponding Celsius value. Then we move the value of Celsius into msg.payload and return that value as part of the function. So let's save that, and let's clean this up here, and everything looks good. Let's redeploy. Okay, so that did well. So we are inputting 40 Fahrenheit. Let's see what is the equivalent. So it's about 4.4 Celsius. Pretty cold. So that was again a way to use a function to create transformation or change data. Let's look at another example where we do the reverse, where we are getting Celsius and we are converting it, or we require it to be converted to Fahrenheit. So let's change this to Celsius. So whatever comes in, it's saved in a variable we define called Celsius. Then we are now calculating Fahrenheit. This is Celsius, and the formula is actually the reverse, which is 9 divided by 5, and then we just need to add that 32. Okay, and so we need the new value here, which is Fahrenheit, and we return that value as the message. Okay, let's try that out now. So let's clear this up, let's redeploy. So everything looks good. So let's change this to make it the right name. So it should be Celsius to Fahrenheit. That's our last and fourth example. So we are putting in 40 degrees Celsius. That would be pretty hot. Let's do something like 24 degrees Celsius, more ambient temperature. And when we execute that, you see that we get a corresponding value of 75.2 Fahrenheit. So that was just a quick tutorial on function. We saw how powerful it is. It is a core node. So I would really encourage you to look into the function node, see how and explore new features of it, using different ways to transform the incoming data. And again, it's a very powerful command, and because it's using the JavaScript functionality, so if you already know JavaScript, it'll be a much easier learning curve. So thank you for watching, and I'll be linking the tutorials that we've done earlier, which will help you to get started on using Node-RED. So thank you for watching.